Unit 3, Lesson 11. Let's look at some applications in factored form. So let's recall the relation in the form y equals a times x minus r times x minus s is a quadratic. The x-intercepts, this is a quadratic in factored form, and the x-intercepts given by this factored form, or sometimes you call them the zeros, are given by r and s. So when we are looking for the minimum or maximum value of a quadratic relation, we are looking for the y-coordinate of the vertex of the parabola. Okay, and we can use the factored form to find the vertex. So if you visually look at what does the factored form represent? So if I drew a coordinate axes, x and y, well, I have a parabola. Let's draw a parabola like this. Each x-intercept, this would be my r and this would be my s. So I'm going to write r and s like that. You're going to have an axis of symmetry, and you're going to have a vertex right there. Vertex. Okay. Now the vertex has a coordinate. Okay, the vertex coordinate is, we'll just say x and y. And x can be found from the factored form. Remember, x is the average of your x-intercepts. The average of the x-intercepts gives you your axis of symmetry. It's the halfway point, the midpoint. So r, if I add r and if I add s and I divide by 2, that will give me my average. That will give me my x value. Okay. And then how do I find the y value? Well, you substitute the x-coordinate into the equation. EQN is short for equation. And you solve. And solve for your y-coordinate. And that's that. That's it. Okay. So let's look at some examples on applying a factored form. So the revenue R. So if revenue means the money that you're collecting, the money that you're earning as a concert venue, let's say it's concert ticket sales at a local venue, is calculated as the number of tickets sold times the price of the ticket. The current price of a ticket is $20, and the venue typically sells 100 tickets. For each $1 increase in the ticket price, 10 fewer tickets are sold. So the revenue can be modeled using the equation R for revenue equals 100 minus 10x times 20 plus x, where x represents the number of $1 increases. Okay, so rewrite the equation in the form R equals a times x minus r times x minus s. All right, so let's just try to understand the situation. Revenue is equal to the number of tickets that you sell times the price per ticket. So if you sell 100 tickets, well, it's going to be, and each ticket is $20, your price would be 100, your revenue would be 100 times 20, okay? But we're looking at changing the price. So if x represents the number of increases, we're going to increase the price. So 20 plus x. So if I have 5 increases, that'll be 20 plus 5. If I had 9 increases, it'll be 20 plus 9, $29, right? And then for every increase in price, you're going to sell 10 fewer tickets. So if I increased it by $1, then 20 plus x becomes 21. So this would become 21, but you would lose 10 tickets because 10 times 1 is 10, and 100 minus 10 would be 90. So you only sell 90 tickets instead of 100. So you have to balance it out correctly. You have to figure out how many increases can I get for x that would maximize the amount of revenue I get, okay, without losing too many ticket sales. So let's look at number A. Let's rearrange. So if I have R equals 100 minus 10x, in the first bracket, the number of tickets sold, and then 20 plus x, which is my price per ticket. I'm going to rearrange that. I'm going to write the negative 10x first. So negative 10x plus 100 in brackets. And then I'm going to write the x first, so x plus 20. Okay. And then let's see, I'm going to factor out a negative 10 from the first bracket. So negative 10 comes out. x. 100 divided by negative 10 is negative 10, so x minus 10, and then x plus 20. Okay, and then by doing this, I get a much more clearer factored form that will help me find the x-intercepts. Okay, so let's sketch a graph of this parabola. So x-intercepts, let's start there. So the x-intercept, this is when y equals 0, or we could say revenue equals 0. Okay, so x-intercepts, the first bracket here, x minus 10 equals 0. So therefore x has to be positive 10. And the other bracket, x plus 20 equals 0. So x has to be negative 20. All right, so we can plot the x and y intercepts, one here at negative 20 and the other one here at positive 10. And I'm just sort of estimating my scale here. It's just going to be a sketch. It doesn't have to be super accurate, just relatively accurate. Okay, so the y-intercept, it's another point we can plot. So the y-intercept is when x equals 0, or you could say the r-intercept if we're dealing with revenue. Okay, and so you take the equation, r equals negative 10, substitute 0 for x, so 0 minus 10 in the first bracket and 0 plus 20 in the other bracket. And so that would be equal negative 10 times negative 10, 0 minus 10 is negative 10, so that'll give me positive 100 multiplied by 0 plus 20 is 20, and 100 times 20 is 2,000. So I have a y-intercept of 2,000. Let's put that point up here. Okay, and so we're going to say that's 2,000. And now let's find the vertex. So the vertex X-coordinate is just the average of the x-intercepts. So if I take the 10 and the negative 20, so plus negative 20, divide by 2, I get negative 10 over 2, which is equal to negative 5. And I can find the y-coordinate by substituting that back into the equation. So if I substitute it back into, I'll use the first one given to us in the question. So r equals 100 minus 10 times negative 5. And that's the first bracket. The second bracket is 20 plus x, so 20 plus negative 5. And if you evaluate that, you would get 2,250. And so that's going to be the y-coordinate of my vertex. And I can plot that point as well on the graph. So here we go. Let's say somewhere about, let's see right here. There's my axis of symmetry at negative 5. My vertex point will be a little bit higher than 2,000 here at negative 5 and 2,250. I can sketch my parabola. There we go. Okay, let's follow it up with part C. So what does the R represent? The R-intercept represent? So the R-intercept, or the Y-intercept, is the coordinates 0 and 2,000. And so x equals 0. So this represents no price changes. So if we had 0 price changes, 0 $1 increases, so this represents no price changes. So at no price changes, what is our revenue? The revenue is $2,000. Okay. What do the x-intercepts represent? Well, the x-intercepts, let's write down what the x-intercepts are. So they are at negative 20 and 0, and 10 and 0. This is when your revenue or your y equals 0. So y equals 0 or r equals 0. Okay, so when revenue, this is when your revenue is 0. No, you don't earn any money. So revenue is $0 if the price is increased 10 times, or the price is reduced 20 times. 20 times is obvious because if your ticket price originally is $20 and you reduce it $1 20 times, it's zero. Zero tickets, $0 tickets, free tickets basically. But if you increase it 10 times, so $10 more, to $30, no one would be interested in purchasing tickets because it would be too expensive. Okay. Let's answer this question. What does a negative value of x represent? So a negative value represents a decrease in the ticket price. So a decrease may not have occurred to you because the question sort of hinted, well, how much do you have to increase the price? Well, you can also decrease the price to get maximum value. So what price will maximize the revenue? Well, if we had only charged $20, we'd only get $2,000 of revenue. If you look at the Vertex gives us an indication of what the maximum revenue will be. So the maximum revenue is $2,250. You can earn $250 more than we would expect if we reduce the price 5 times. So minus 5 means the number of price changes for the maximum revenue. So minus 5. So we're going to reduce it 5 times. So the revenue, remember, the revenue is equal to 100 minus 10x, and that's multiplied by 20 plus x. 20 plus x is my price. 100 minus 10x is the number of tickets sold. TIX for short. So the price that would maximize the revenue is equal to 20 plus x. And so if it's x is negative 25, I'm going to do 20 plus negative 5, which is $15. So a price of $15. So therefore, a $15 price for your tickets will maximize the revenue. Okay, let's look at one more example. So example number 2. The flight of an aircraft from Toronto to Montreal can be modeled by an equation, a quadratic equation, h equals negative 2.5 t squared plus 200t, where t is the time in minutes and h is the height in meters. So let's sketch a graph of this relation. So part A, we need to find the factored form to get more characteristics for a parabola. So if h equals, let's write the equation, negative 2.5 t squared plus 100t. I'm going to common factor. So check, can I divide both terms by negative 2.5? And it certainly works. I can divide this first term by negative 2.5, and 100 divided by negative 2.5 gives us a nice answer as well. So negative 2.5 divided by negative 2.5 is just t squared. So create your brackets, write t squared, put your common factor outside, negative 2.5. Again, it's like the reverse distributive property. You're just common factoring out a negative 2.5. And so it comes out here. And 100 divided by negative 2.5 is negative 80, so minus 80. And don't forget you still have a t. Okay. I can also common factor out a t, so I'll put negative 2.5 t. And so t squared divided by t is t, and then 80t divided by t is just minus 80. So our x-intercepts, or our t-intercepts, would be, from this guy would be 0, and from this factor here would be positive 80. So t equals 0 and t equals positive 80. Now, axis of symmetry, I can also find that by averaging our t-intercepts, so 0 plus 80 divided by 2. And so that's equal to 40 divided by 2, which is equal to 20. And I can also find the height for our vertex using the equation negative 2.5 t squared. T will be replaced with, I'm sorry, I made a mistake here. 0 plus 80 is 80. I jumped the gun. And then divide that by 2 is 40. So my axis of symmetry is 40. That's what I'm going to substitute. So t squared, so 40 squared plus 100 times t, so 100 times 40, which equals to 4,000 if I evaluate the entire equation. So h equals 4,000. Therefore, my vertex is the x-coordinate, which is the axis of symmetry at 40, and its corresponding h-coordinate, which is 4,000. And then I plot the graph. So my x-intercepts here are 0, and 80. We'll put 80 over here at the other end. And this is my t-axis. So my x-axis is just called my t-axis, and my y-axis is called my h-axis for the height. And then you draw your axis of symmetry roughly halfway, you're at 40. And then your vertex will be a point up high at 40,000. And then you draw your parabola. Oops, there you go. Let's just move the points. There you go. Done. So part B. So we'll just talk about the parabola. So the parabola models the height of the plane. The plane takes off, reaches a height of 40,000 meters, and then comes back down after 80 minutes, all the way down to back to the ground. So how long does it take to fly from Toronto to Montreal? Well, takeoff and landing. So takeoff and landing happens when h equals 0. So takeoff and landing happens on the ground. So that's when the height equals 0 at the ground. And this happens at 0 minutes and 80 minutes. So therefore, it takes 80 minutes to fly from Toronto to Montreal. Part C, what is the maximum height of the aircraft? At what time does the aircraft reach this height? So the maximum height is at the vertex. So that vertex point is 40 and 4,000. 40 represents the time and 40,000 represents the height. So that's my vertex point. And so we could say the aircraft, therefore, the aircraft reaches a maximum height of 4,000. Oh, I made a mistake up here. It's not 40,000, it's 4,000 meters. So I just correct the graph there, 4,000. The aircraft reaches a height of 4,000 meters at 40 minutes into the flight. Okay, and those are my two examples on applying the factored form. And that ends this video.